Okay, in this video we will see how to plot experimental data, any kind of experimental data using MATLAB programs. Right, so here you can see this is the command window of MATLAB. Whatever program you execute, its output will appear over here, and if the output is a figure, then it will appear as a separate window. This is the workspace where you will be able to see all the variables. Okay, and this is the program window, right? This is the basically MATLAB program. You can go to file, new, and click on blank M file, and you can create a new. So I have already created a file. CLC is for clearing the screen. For example, let's say in the command window I have written a equal to 1. So you can see this is the output of the command a equal to 1, that is also shown, and in the workspace also you can see the variable is appearing over here. I can double click on this variable and I can see its value, and then minimize it from here, minimize variable editor. Okay, now if I want to clear this command window, I will have to execute this command clc. So typing clc, and at the end there is a semicolon, enter. Now I press F5, so the program gets executed, or it will first ask you to save the program also. So for if it asks you to save, you can save it like this. Don't use any space between the two words, make use of underscore. Here you can see I have written plot underscore and not plot space. Okay, save the program and then run it. So here you can see after execution the command window has been cleared due to application of this command clc. Now I write clear all also. This generally we write at the start of every program. So now I press F5. Here you can see on the workspace a variable a is appearing. Now if I press F5 now, that variable will go away. It basically clear all command, it clears the workspace, basically clears, wipes out the brain of the MATLAB processor. There is no variable present as of now in the workspace of MATLAB. Okay, now what I do, I define any general variable. Let's say input underscore data is equal to 0. So that variable is defined. Now I go to Excel where my Excel sheet of experimental values is there. So there is a input X and output Y. So this I will treat it as input data. So you can see there are total uh, total uh, 99 values, right? The size is 100, size of the matrix is 100, but the first is only the legend X and Y. So 99 data points are there. So I will simply copy these data points from here. It's very simple how to transfer data from Excel to MATLAB. Right click over here, copy. Okay, now go to MATLAB workspace, double click over this, right click over here and then paste. Okay, and then minimize this also. Now you can see if I write over here input data and press enter, it will show me all the values which I have pasted. Right, now I will have to first save this data also somewhere, like we do in Excel, we save the file somewhere. Here also we will save the data file, so that later on we don't have to every time go to Excel, copy the data, paste it into MATLAB. That thing is not required every time. For that what we will do, हम इसको डाटा को सेव कर देंगे, राइट क्लिक किया, सेव एज कर दिया इसको, and you can name the file as input underscore data underscore 1. Okay, let us keep it input underscore data itself, and then save. So in the folder you can see a file has appeared over here, input underscore data, right? This is a MATLAB mat file, this is a data file which I can access later on. Now here I say okay, let me first clear this file, clear all. So in the MATLAB processor you can see our experimental data is passed out, it is gone. Now we will recall it. Let us see how. Load brackets input underscore data semicolon. Now press F5 and you can see this has appeared. Now if I click here you will see the data has appeared over. Now what I do, I will make use of this data. I will say that okay, x is equal to input data, it's all the rows comma first column. Okay, now let me remove the semicolon so that side by side I will able to see the output also. Input data, it's all rows and first column, so it is saying undefined variable input underscore data. Because here I have written small d, actually it is capital D, right? So let me make capital D over here also and capital D over here also. Now press F5. So here you can see the x variable has been defined. It's a vector containing all values of first column of experimental data set. Now I say okay, y is equal to, again same thing, input data, it's all rows and second column, right? Now press F5. So x and y are defined over here also. You can see this is x and this is y. Okay, now you simply give this command plot x comma y. Now press F5 and it will show you the plot x versus y. This is a quadratic curve. Basically it is y equal to x square. I have taken the data into that specific format while preparing the Excel sheet. Now the next thing is to let's say add some more things to this. Let us say I say that okay, this is not y, this is y1, and here also I will say this is y1. Now press F5. So x versus y1 is plotted now. Let us close this. Now I define another variable y2 equal to okay, y1, and its each term is squared, so that means it's finally it will be x raised to the power 4. Okay, now I again write over here x comma y2. So on the same plot there will be x versus y1 also and x versus y2 also. So this is x versus x square quadratic curve, and this is x raised to the power 4 curve, right? So there seem to be so much difference. So let us say instead of using this square sign, let me take plus 10 sign, plus 10 value here. So that will be easy to understand. So here this is the y1, the blue colored is y1 and the green colored is y2. So basically y2 is y1 plus 10, right? Okay, now there are many other things. Let me open a pre-existing file, MATLAB plots, plotting this. Okay, here you can use many things over here. I simply copy this thing from here and go to this my file and paste it over here. Now instead of writing this, I can delete this one, and here I am writing the figure name also, figure numbering, figure 1. Okay, that is just to number the figure. Then what I want to plot, I want to plot x comma y1. Okay, and z just to stop the processor over here, because processor doesn't know what is z, so it will stop over here. The rest of the command will not be executed. Now press F5. So here you can see the output of the program. It is plotting x comma y1. On the x-axis there are x values, and on the y-axis there are y1 values. And this term, this is basically deciding the color of the curve and the type of the curve, whether it will be continuous or dashed. In this case it is dashed. K tells it that the color should be black. Dash tells it that it should be a dashed line, and O tells the type of marker. I want to use O as a marker point, right? And next I am defining the line width. Line width must be 2. Let us play with this. Let's make the line width as 10. Now let's see the effect. So this is the line width 10. This is the line width 1, and the plot is over plotted on the same plot, overlaid on the previous plot, so that is why it is not visible. So let us close this figure 1. Now press F5. So you can see now the curve is drawn with the line width of 1. And if you, instead of O, here you can see O is being used on all the marker points, O, right? So instead of O you can use some other format also. Let us close this window. You can use a dot also. Now press F5. So here you can see O is not shown, it is only a dot at the marker points, at the data points. So how to get this description, whether K will be black or some other color? If you want to use red color, type R, press F5. So here you can see color has changed to red. Let me increase the line width to 5. So you can see the color is now red color, right? Line width has also increased. So very simple thing over here to note is help space plot enter. So you will be able to see all the description related to this command, right? It is used for a linear plot. Then the command description is given. So basically this is the command plot. Then its format is told that okay, a bracket within the bracket x comma y. So what does it do? It plots vector y versus vector x, right? It plots vector y versus vector x. And these are the different options, like B will be used for blue color, G for green, R for red, and as we did earlier, A is for black, right? Then the marker points also, marker options also, dot for a point, O for a circle. If you want to use a cross mark, type X. You can use a plus sign, you can use a star sign, you can use a square sign also, or even a diamond shape also. There are many options available. Further, the joining line can either be a solid, it can be a dashed line, it can be a dash dot, right? It can be dotted, or it can be dash dot, or it can be dashed. Or if you don't want to draw the line, joining line, you can simply write none over here, right? So instead of this dash, let me erase the dash and close this figure. Now press F5. So here you can see no joining line is drawn, only the marker points are drawn over here, right? And the marker points can also be changed. For example, let us make it diamond type, so RT. So this, the diamonds are too close to each other. The diamonds are drawn, diamond shaped marker points are drawn, but no curve is drawn, right? No joining curve is drawn. Okay, if you want a joining curve, you can type a dash or some other required format, and type D, press F5. So here you can see, although the joining curve is little bit visible over here, here you can see the joining curve is visible when I zoomed over here, right? How to zoom? Click on this plus tool and then you select the area and then release. So you can this way zoom in and zoom out. Generally this is not required. This is done just to zoom into a particular area and see the curve, but for plotting purpose this is hardly used. Close this window. Okay, now let us explore other things. next command is hold on. Hold on means I want to draw another graph on the same graph window. That means hold on. Hold this graph and then I will draw something else also on this. So how to do that? Hold on and then give another plot command, again x versus, now here I am writing y1. Sorry, this will be y2, right? Okay, now z, press F5. So here you can see this is y1 red curve and this is y2 blue color. Okay, similarly you can draw other things also, other curves also. Okay, then you can also define the x limit and y limit, right? So for example, at present it is by default based upon the data sets, it is taking the default value, but means 0 to 10 for x. So I can write that x should vary between 0 to, let's say, 5, and y should vary, let's say, between uh, minus 10 to let's say 50. Now let us see the effect. So here you can see x is varying from 0 to 5 and y is varying from minus 10 to 50, up to 50. So y varying between minus 10 to 50, x varying between 0 to 5, and here is how we decide this. So here instead of this I can write 10 and here I can write 100. Now press F5. So here you can see the graph has changed. Basically the limits of the graph have changed. And again, next thing, you can define a variable font size. Whatever you want to write, x-axis title, y-axis title, legends, that will be decided by this font size variable. So at present I am taking it to be 36. Let's reduce it to 10. Now give this command set GCA is for graphical coordinate axis, and again GCA graphical coordinate axis, you are defining the font name. Always use Times New Roman here. Okay, next thing is you write the X label, right? X label. So what is that? So here X label will be written. You can see it is time in hours, right? And it is Times New Roman and size is 10. Let us increase the size, font size to, let's say, 36. Now press F5. So here you can see font size has increased. Labeling font size has increased, right? And always use this description. You can simply copy paste this thing, right? And whatever you want to write here, whether it is time or whether sometimes it is the input value is displacement or force or whatever, right? Displacement or velocity is generally the input, or any other input variable that you can name the variable over here, right? Now press F5. So here you can see it is mentioned here displacement or velocity or any other input variable, and side by side you can mention the units also. Okay, now for y label, again same thing will be used. Now let us see the effect here. F5. So here you can see temperature is written now and degree Celsius is also written. How to write this degree word over here? So that is using this format, tilde, then backslash, and then O. So that will make up as a degree, right? Sometimes you need to write meter per second square. So m oblique s square. So let us see the effect. So this is m oblique s2, not square. So how to make it square? Use a tilde over here. Now press F5. So here you can see now it has become meter per second square. Okay, this font size basically it takes the value of this variable font underscore size. This font size is a MATLAB, you can say command kind of thing, right? It has to be written this way only, and this font underscore size is our variable which we define it to be 36, right? Okay, next thing is legend. here you can define the legend also. For example, over here, if there are only two output parameters, so I will have to remove the third legend. So pressing F5. So there are two parameters. First graph is this red colored graph is related to solar air temperature for wall, and blue colored graph is for solar air temperature for window. Right now, next is whether you want to show the grid or not. Generally, we like to show the grid also. At present, you can see no grid is present. So if you want to show the grid, press F5. So you can see now the grid marking lines are also there in this graph. You can see the line here, over here, this one, and this one also. Vertical and horizontal grid lines are available now. Okay, you can also decide the tick mark options by selecting the axis. So I am defining AX equal to GCA, and here using this command you can decide the tick marking option also. Let's press F5, and in this particular version of MATLAB this command is not working, but using this X tick option you can decide where to mark the ticks. Okay, that is all about how to transfer your Excel data into MATLAB, and then how to save it, how to recall it using this loading option, and then define different vectors, and then define figure number here, and then simply use plot command to draw the plots. And here use X label command to write X label, X axis label, Y label command to write Y axis label, legend command to write the legends.